But did I ever tell you about the letter that Phoebe wrote me to try out for softball late last year?
Oh, yeah.
It was very funny. That's what made me say yes. I laughed hysterically when I'm reading it. So, something like, so Mr. Lindquist, I tried out for lacrosse and didn't exactly work out.
Look, my brother gave me some bad advice.
Yeah. And then she goes, and then some friend of yours said you should try out for softball. And she goes, I should have listened to her. So.
Because all my brothers played lacrosse, so they were like, yeah, go play lacrosse. I was like, okay.
Yeah, that didn't work out. So, anyway, we're happy she played softball. Now, which of the following choices is in the solution set? So that means that when I plug it in, it's got to check and work. So I'm just going to try the smallest answer here, or a answer here. Let's see. I'm going to try -4 and see if it works, just to plug it in. -2 times -4 is 8. 8 plus 5 is 13. 13 is less than 15. It checks. So -4 is going to be the answer. Of course, we could also, and preferably, actually solve the inequality. So I subtract 5 from both sides. -2 n is less than 10. Then I divide by -2. And it's at this point in time that we have a danger moment. What's the danger? The sign. What about the sign? Yeah, you got to change the direction of the inequality. N is greater than -5. I want you to realize you're changing every sign in this problem. It's not just one sign. This was a -2n becomes positive. Less than becomes greater than, and +10 becomes -5. So when you negate, every single sign is changed from the positive negative signs to the inequality sign itself. Questions? Okay, next, go ahead.
If you got -5, then how would you get -5?
It says n is greater than -5. So which of these choices is greater than -5?
Understood.
Only -4 is greater than -5. -5 would work out to be equal, but there's nowhere equal to symbol under here.
Okay.
Next, in the space below, graph each of the following. Now, I don't think I did too much of this the other day, but this is pretty easy. This is a bounded interval. Take a look at this, ready? When I describe this as a bounded interval, does that make sense?
Nope. No.
Doesn't it look like it has an area where it begins, or a place where it begins, and a place where it ends?
Yeah.
Doesn't it kind of look like that? So when I graph it, let's put those two places there, -2 and 5. Bless you. Now what we're going to do, it sounded like one of those sneezes where you're done and you get boogies all over you and you're like, oh. So it's one of those worst boogies. There's different kinds of sneezes. There's the blubbering sneeze, and then there's the kind of sneeze as a teacher where you're in front of the class and you're like, oh, did I get it all? I mean, is there something still hanging there? And then you get the kids start laughing, and you get really, really worried. You're like, okay, God. And then you see if they keep on laughing, and then if it gets even louder, you're like, oh, God. It's either that or my fly's open. Which one is it? It's terrible. So, all right. So the endpoints are -2 and 5. Okay? Now, am I allowed to equal the -2? Yeah, so I got to fill that circle in. That I'm sure you remember. Am I allowed to equal the 5?
Yeah.
So I fill that circle in. Some kids say to me, I forget whether the line underneath, if you fill it in or if that's open. This is a stupid way of remembering it, but it works for me. If there's a little line underneath, you pick that ink up and use it to fill the circle.
Oh yeah.
Okay, yeah, so it works. And then you connect it in between. When you connect it in between, make sure that you raise up above the line so I can see that there's more there than just the line. Some kids try to be so neat, Christina, I'm worried about you. Some kids try to be so neat that, like, if this is the thing, they'll go like, and I can't really tell if that's the line or not. Make it obvious that you're above the line. Yes?
Just make it darker. I don't call
It's got to be clearly obvious that you're connecting those 2 points. Okay. Next, x is greater than 7 or x is less than or equal to 2. See, this statement here is an end statement, even though we don't necessarily write the word end. It's bigger than -2 and it's smaller than 5. The next one, it's greater than 7 or it's less than or equal to -2. Now, we already talked about the fact that it's 4 equal. We're going to fill that circle in. But now it's not greater than, +2. It's not greater than +2. It's what? less than. So when the letter's on the left, the arrow goes in the same direction. And then this one is an open circle on 7, arrow to the right. So here's the big difference that you need to remember. Do you see the word or? Right? Do you remember the song years ago? I don't know if you actually listened to this song, but last year when I said it to the kids, they all remembered the song. Do you remember that song, Walk Like an Egyptian?
Yeah.
Okay. Now, I don't watch MTV. I don't know the lyrics. It's just, at one point it goes like, walk like an Egyptian. Now, I don't know how to dance, and I certainly don't know the lyrics to the song. Okay, there we go. We got the head bob going, but at some point in time they go like this too. So every time I see an or statement, I think of walk like an Egyptian. Okay? So it's like you take your hands and you push them to the side. All right, so that's what I think of when I think of an or statement. All right, next up, simplify each expression. The big thing to remember here is the cube applies to everything. This is the kind of review stuff that you will see on your test coming up. So it's all over your review relearn packet. So by doing your relearn packet, you're actually helping yourself get ready for your next test. 4 to the third is 64. N to the 4th to the 3rd, raise a power to a power, is n to the 12th. Yes?
How'd you get that?
The cube applies to the 4 and the n to the 4th, agree? 4 cubed is not 12. 4 cubed, did you have 12? You did, didn't you?
No.
What's 4 times 4?
4. So we're 60.
Times 4, 64. Then n to the 3rd to the 4th, I multiply and I get n to the 12th.
Wait, whatever.
I agree. Now, now let's go raise this guy, a chance to do it again. Sam, what do you think you get when you raise 2x to the 3rd to the 4th?
Do it again.
What do you think when you raise 2x to the 3rd to the 4th? Do 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 do. Up! Would you please correct her for me?
16x to the
2 is 8, so 8x.
To the 4th.
2 times 2 times 2 times 2. Oh!
You said 8 times 2.
16.
16, good.
I'm sorry.
X to the 3rd to the
Oh,
4th.
I was doing 4s.
No.
7. 12. I thought you added.
It's multiply.
No, you multiplied it.
No, I don't mean like you add 3 plus 4.
We're great at this.
Well, I meant like 3 times 3 times 3
What
times
I
3
got
and
wrong
then
on
add
my
the 3.
Yes, if you write it out, that would be a good way to do it. I'm with you. I understand. You are exactly right. It's the same thing done from a different point of view. Okay. Now, don't forget the 4x in front here. So 4 times 16 is 64. Now I'm going to add the exponents. I get x to the 13th over 8x to the 5th. 64 divided by 8 is 8. Subtract exponents, x to the 8th. That's a tricky question because it involves the order of operations and all 3 exponent laws. If you can do that question correctly, you can do any exponent law question, period. You can do them all. Okay, next. Negative exponent. 5 halves squared, which is 25
no,
over 4.
Oh, I got that one.
Okay? I got it right. I got it right. Okay, yes.
I never understood that. A lot, and every time like we win a board game, you have to do the winner dance, and I hated it. And then my mom finally made me do it one year, and now I always do it when I win.
Well, that's it. You got to win. You kick the other people's butts.
And then,
No mercy. Yes.
Why do you switch it around? But that's
Switch it around. You mean take the reciprocal? Because of the negative exponent. We went over that. Like if I do x to the 3 over x to the 5, that's x to the negative 2. But if I look at it this way, if I go die-die, I get 1 over x squared. So the negative puts it in the bottom. Okay? Yes? That you just use, oh, no. The only thing about that is, though, that if there's variables and you just use a calculator, then if you only use a calculator and then you get to the part where you need variables, you won't know how to do it. Okay? All right, so now, some pretty straightforward stuff. I want some words that you take from algebra and you translate them into mathematical operations. For example, one really easy one is, or phrase, is more than. And there is a sister phrase for that, if you will. For subtraction, it would be what?
Less than.
Less than. Nice. Okay. Some more phrases. Just give me a phrase and we'll put it in the right one. Go ahead. Plus. The sister phrase for plus is? Minus. Good. What do we got now? Obviously subtraction. We know that. I'm sorry? Sum. Good. And the sister phrase for that is difference. Okay. What do we got next?
Product.
Equal to is not an operation. It's the sign. So we do have to know that, but we're looking for operations here. No, greater than again is a symbol. Okay.
Same thing as more than.
You're not going to read, I don't think, greater than. To be greater than is to be more than. That's true, but they won't say like. They might say it's greater than a number, less than, maybe, but it's typically not what we're looking for here. Go ahead. Total can be add, subtract, multiply, divide. More.
Wait, can we do?
Times, that's a multiply.
So we are doing those product.
Here, product. Of. Quotient is the only one for divide. Of is important. Of is used for fractions and decimals and percents. Okay, yeah. Add is increase. Subtract is decrease. Okay? So that's not an exhaustive list, but it's a very good list. And as we come across more, we will use, well, again, twice this period.
What?
Went for the wrong one. Okay. I watched them laugh hysterically at me before. Okay. Yes. Now, 3 more than a number n. What's an algebraic phrase for 3 more than a number n? Hunter. N plus 3. And I want you to notice something here. It only applies to more than and less than. It does not apply to any of the other translated phrases. More than and less than, you always switch the order. And the best way I can explain it is Bruce Springsteen has a song called The Ghost of Tom Joad. And in The Ghost of Tom Joad, it quotes scripture. And it says in the song, I'm waiting for the day when the last shall be first and the first shall be last. So, the last, N, shall be first, and the first shall be last. So apply that to number 2. What do we get? N minus 5. Good, because the last shall be first and the first shall be last. It's catchy. I like it. What about 7 less than 4 times a number? 4n minus 7. Good. That's very common. We do that all the time. 8 increased by a number n. 8 plus n. Now, it does equal n plus 8, so you could also write that, and in time that would normally be what we would write, just because we tend to do standard polynomial order. 10 decreased by twice a number n. 10 minus 2n. Good. The product of 7 and a number n decreased by 2. Were you with me on that?
Yeah.
Right? Product means multiply. 7n minus 2.
Y'all have to slow down.
I am
She's
just-
just shouting around over there.
I am an idiot. You could absolutely live in Alabama, Phoebe. Okay, next.
My dad wants to move to Alabama.
4 less than the quotient of a number in 5.
Oh my gosh, if you talk like that, I wish you could.
You know, if somebody listens to this video, they're gonna go, how politically incorrect is this teacher? All right. I think people need to get over the whole politically correct thing. You gotta man up. Okay, next. You've got a country of wimps. Twice the another one. I'm gonna get myself in trouble. Okay, I can see like some far left liberal going, oh, this man is a horrible human being. Twice the sum of a number and 1. This is careful. You gotta be careful on this. Right. It's twice the sum, so 2 parentheses n plus 1. All right, hasta la vista, vaya con Dios, toodaloo, ta-ta. Arrivederci, smile a lot, ciao, arrivederci. Pretest starting tomorrow.